Welcome, everyone, and thank you for joining us today. My name is Kara, and I'm with the Ohio LTAP Center here at ODOT, and I'll be your host for this webinar. Today's webinar is Ranking Ohio's Roadways for Safety Improvements in AASHTOWare Safety, and we are excited to have Greg Olson as our presenter. Before we begin, I'd like to cover a few housekeeping items to ensure a smooth webinar experience for everyone. If you have any questions during the presentation, please use the questions panel on your screen. You can type your questions there, and we will address them either as we can during the presentation or during the dedicated Q&A session at the end. If you are experiencing any technical difficulties or have any other issues, feel free to use the chat panel to communicate with our team, and we'll do our best to assist you. Please note that this webinar is being recorded, and the recording will be made available to all registered attendees after the session. All right, with that out of the way, let's get started. It's my pleasure to hand it over to Brent. Brent, the virtual floor is yours.
All right, thank you, Kara. Good morning, everyone. Thank you for joining us today. My name is Brent Dogart. I serve as a state safety engineer in the highway safety program at ODOT's central office. And before we dive into training, I just wanted to share a little background. ODOT adopted AASHTOWare Safety primarily for its network screening capabilities and as a modern replacement for safety analysts, which we had historically used to generate our highway safety priority lists, and we've successfully used AASHTOWare Safety for the last 2 cycles of generating our HSIP priority lists. The transition has allowed us to expand access to network screening tools, not only for our internal teams, but also for external partners. And we've opened these applications to our entire user base, which is getting close to almost 1,000 people now. And we're excited about the wide range of potential use cases this enables. Today's training will cover the differences between the network screening applications and walk through how to create a network screening analysis using a few examples that ODOT's generated and used internally. So with that, I'll turn it over to the Numetric team to get us started. Thank you.
Awesome, thanks, Brent. All right, let me get the screen share going here. Okay. Thanks for the introduction, Brent, and thanks to everyone over at the Ohio LTAP for putting this together. They did a great job in coordinating everything and getting the invite set up and facilitating the webinar. So big thank you to everyone over there. They're great to work with. Excited to be here with you all today. My name is Greg Olson. I work for Numetric. We are the official software provider for AASHTOWare Safety within Ohio. We have been working with Brent and his team in Ohio for a while now to get all the applications set up and configured and rolled out across the state. We have previously done some webinars and trainings in some of our other applications. We're really excited to be here and to be talking with you all about our latest applications that we're rolling out, the network screening tools. As Brent said, these are to help identify roadway networks in need of potential safety improvements and to build prioritized lists, things like that across the state of Ohio. So excited to be here and excited to be sharing this with you all today. If you have any questions, as was mentioned, feel free to drop those into the question window and we'll make sure that we get those taken care of as we go throughout the training today. With the number of attendees that we have on here, please keep those questions coming in real time. We will have some time at the end for kind of an open Q&A, but chances are your question is relevant to something that we're actually talking about at that moment. So drop your question in the chat. If we can, we'll get to it and answer it in line with the presentation. If not, we'll have some open Q&A time at the end that we can address all of those. So thank you all for taking the time out of your day to meet with us. This should be a good session that we're going to run through today. I've got a few slides that we're going to be taking a look at. But the bulk of our presentation today is actually going to be hands-on in the applications. So if you do not have access, to your account, or you need help unlocking your account, anything like that, Kara just dropped some instructions in the chat. So take a look at that, and that should, I've got the hiccups. That should help you get your account resolved, and we can get you following along. If you do have the ability to follow along, highly encourage it for the training today. It's largely going to be hands-on. We're going to be running through several different examples and putting together some custom screenings. So again, really encourage you to kind of follow along if possible. If not, no problem at all. We will have this recorded and we'll share that out with you. So let's dive in. So today we are going to be talking about network screening. Now, network screening is not just a concept as outlined in the Highway Safety Manual. Network screening is also what we call the applications that help do the network screenings. So our network screening applications help you conduct either a segment, an intersection, or a sliding window analysis. Now, if you have used our other tools, Crash Query, before, then it's going to be very similar look and feel, but what you're actually looking at in network screening is going to be a little bit different. Rather than looking at crashes on a map, we're actually ranking those intersections, segments, or windows according to different measures. So our goal when using network screening is to leave with a list of potential areas for improvement and further investigation. These can be high crash lists, high severity locations, lots of different ways, measures to rank the lists by. But that's kind of our key deliverable with network screening is here's your list of areas for potential safety improvement. And then again, you can go investigate those areas and see if there's actually improvements and countermeasures that can be selected for improvement. We're going to talk today a little bit about the different ways that we can measure them as well. We have the ability to do standard kind of observed or historical network screenings. So looking at things like high crash counts, high severity locations, things like that. We also are going to take a look at and get into a little bit some of the predicted methodology that we can use where we're utilizing those SPFs to help rank by a more predictive model following kind of the HSM guidelines. So as we go through the applications, we're going to be looking at several different applications, but they all function very similarly. So we're actually going to be taking a look at about 6 different applications, but the filter bar is all there. The mechanics of the application is the same. It's just what you're actually looking at that is changing a little bit across the board. So don't feel too overwhelmed. Also, if you're not super familiar with network screening, if you know some of the math that we're going to talk about or some of the calculations we're going to get into, if it feels a little overwhelming, don't worry too much about it. You don't actually have to do any complex calculations or anything like that. The tool itself is extremely simple to use. What is happening on the back end of the system is pretty complex, but none of that complexity is rolling up to the users. So we'll get into some of those calculations just so that you're aware of what's going on, but you don't have to worry too much about really the details of how that's actually being conducted. So we'll also take a look at some of the report downloads and some of the output options from the network screening applications. So as I mentioned, we've got examples that we're going to be looking at as we go throughout the training today. Feel free to follow along, but like change them up a little bit. For example, our first example, we're going to be looking at the wheeling MPO. Chances are pretty good that you don't want to look at the wheeling MPO unless you do, in which case, hey, awesome. But change that to whatever area you want to look at, whatever MPO, city, county, district, whatever it is you want to look at. Kind of, you know, play Mad Libs a little bit with the scenario, change out the location, change out the metrics or the filters that we're looking at. and make it meaningful to you. So, all right. Some vocab to get out of the way, because nothing is as fun as vocab. Just so that we're all kind of speaking the same language. I'm going to be using some terms, and these terms are reflected in the Highway Safety Manual, but I just want to introduce them to make sure that we all know what we're talking about and we're saying the same thing. I'm going to be using the terms, and our applications use the terms observed, predicted, and expected. And I just want to make sure that everyone understands what we're talking about with those. So when we use the word observed, it's also referred to as historical. That's crashes that have occurred. So that's the known crashes. We have a record of it. It's an observed crash at that location. So that's the observed data that we're talking about. So some of the measures that we can use when we rank roads by an observed measure is like the count of crashes, fatal crash count, severity crash count, crash rates, crashes per mile. Those are all based off of known crashes that actually have occurred. The next term is predicted. Now, when the HSM uses the term predicted, it's talking about crashes that are predicted using an SPF. An SPF is a safety performance function, and that's essentially the function that predicts crashes based off of roadway characteristics, volume, and attributes. So we'll take, for example, all of the rural 2-lane roads with a certain AADT. And across the state, we've seen that they behave this way. So we build a prediction model based off of the behavior of those roads. That helps us get kind of a baseline understanding of how a road should be behaving. So that's really kind of what predicted means. It's, hey, based off of the behavior of similar roads, how should this area be behaving? How many crashes should we be seeing? Predicted is great because it gives you kind of a comparison point. Predicted doesn't really tell you the behavior of the road, it tells you how the road should be behaving. You can then compare your observed or your expected crashes to that predicted value. You can see if your road is performing better than normal or worse than normal. It again gives you kind of a comparison point. The last term that we're going to look at and see in some of our applications as well are expected. Expected is kind of a statistical adjustment where we look at the historical crash data and we adjust it a little bit to account for the volatility and randomness in crash data. The technical term is it's an empirical Bayes regression to the mean adjustment. But that means nothing to me, or I don't know, maybe it means something to you. But essentially that means there's the natural volatility in crashes. 1 year you may have 5 crashes at that location. The next year you may have none, even though nothing changed, same volume, same road, crashes are random. So this adjustment helps kind of account for that and normalize that a little bit. So those are the 3 kind of terms that we're going to be using a little bit as we look at our network screening approaches here. On that topic, we actually did have a question from Kessa that says, do the expected crash numbers utilize the full HSM methodology, or is it an abbreviated version? And are users able to get in to tweak the formulas, or is it more of a black box? So we'll talk about these a little bit later. It's not a black box in that we're very transparent, and we'll actually show you the SPF that we're using. These SPFs have been developed based off of Ohio's roadways. We've worked really closely with Brent and his team to put these together and to audit them and make sure that they're representative of the data. You don't have the ability to go in and tweak the function necessarily. So from that perspective, it's a little bit locked down. But it's not a black box in that it's not clear what's happening. We're very transparent, and in fact, we'll show you in some of these SABE screenings that we're going to share with you today we actually do have the SPF itself as a column of data. So you can actually see that function and you can see what's happening behind the scenes. It does follow the HSM methodology. So yeah, we're following that and adhering that very closely. And we actually are on track with HSM2 as it's coming out. We're already working really closely with the HSM2 committee to make sure that we are aligned with any new changes to the HSM as that comes out. So yeah, great question, Kara. We will be talking about the details of that a little bit more as we get going on through the training. So when I get to them and I talk about them, if there's more you'd like me to kind of dig into, or we didn't quite answer your question at that point, drop another question in the chat and we'll make sure we get that taken care of. But yeah, thank you. Let's see. Yeah, so another question around how often are these calibrated? Yeah, we can get into these a little bit more. Good questions, keep them coming. We'll get into these a little bit more as we look at the actual SPFs and the little predicted values in there. But yeah, keep them coming. I love it, this is great. Oh, and awesome. Brent is hopping in with some answers to these questions as well. So regarding update frequency. So keep your eyes on the chat and he'll hit a lot of those answers. So, okay. All right. Now let's kind of talk about a little bit more. We talked about the terminology, but let's look at how this actually shows up in our tool. So when we use the word performance measure, that's just a complicated way of saying how you rank the road. So there's a couple different ways that we can rank the roads. We can rank the roads using our historical or observed performance measures, and those are crash counts, crashes per mile, crash rate, and EPDO, or equivalent to property damage only. And those are all from the HSM. We also have predictive performance measures, which use those SPFs and the empirical Bayes adjusted crash counts. So for that, you'll see that we have predicted crashes, expected crash rate, potential for safety improvement, which we'll talk about a little bit more as well, and then the level of service of safety. So those are the different predictive performance measures that we have available to. Now, our applications are structured around two different approaches to network screening. Two different, I don't want to call them screening methods, but two different approaches to the data for network screening. Again, that historical or observed approach, or the predictive approach. Those are broken into two different applications. Now, we'll get into the why as we start to look at the applications themselves. But the kind of long and short of it is, it's a lot easier and a lot quicker to do a historical network screening. It takes a little bit more time to do a predictive network screening. So because of that, we've allowed you the ability to do either just a really quick historical observed network screening. You get your results back instantly. It's like crash query, you type something in, the results pop up. Predictive, you may need to queue the screening up to be processed, and that can take an hour, 2 hours for it to actually complete and chew on the numbers and give you the results. So because of that kind of difference, we want to make sure that we do have a really rapid historical analysis that's available for you. Once those results are generated for your predictive screening, however, you don't have to reprocess them again. So until there's a new year of crash data available, those results are going to be good and you don't have to kind of queue that up. So that's really the big differentiator between the two, is one of them takes a little bit longer to generate and the other one's a little bit quicker. There are times where you don't need a predictive screening, where you just want to do a quick historical screening. Awesome. You can do that in the historical network screening approach. But that predictive model, if you do want the more complicated advanced predictive and expected values, then it might take you just a little bit longer to generate that screening. So we'll take a look at that and some examples here in just a minute. When you log in and look at network screening, you will possibly see 3 different types of network screening applications available to you. If you see anything that says legacy in parentheses, don't use that word. That's our older code base. It still works and it's fine, but it lacks some of the features of the new network screening approaches that we have. The only reason we have that still in there, if you see it at all, is because there's some older screenings that have been used for the last year or so that we still just need to finish migrating over. Those should be gone within the next month or 2. So don't worry too much about those. Just if you see a parenthetical that says legacy, don't worry about it. Under the network screening dropdown in your applications here, you will see intersections, segments, and sliding windows under just regular network screening. That's our historical, our observed network screening. That's where we're just looking at the historical data. There is another heading down here under predictive network screening. That's where you will also see predicted network screenings for segments, intersections, and sliding windows. That's the more kind of complicated predictive network screening model. So, okay. Now, again, you will likely not see this legacy at all. Hopefully you don't. If you do, though, just to kind of get ahead of it, ignore it, don't use it. It should be completely out of the system very soon. So hopefully it's not there at all. Again, you'll just see the network screening and the predictive network screening applications. So, okay. I promise we're almost there, guys. This, the last thing I want to talk about, and this is going to be really quick, the different methods of network screening. This is how we define the roads themselves. We have 3 different network screening models, again, following the HSM. A segment-based network screening, which is where the roads are broken into different chunks, segments, we call them, based off of the roadway characteristics and attributes. So a certain segment of road will have the same number of lanes, be the same functional classification, different parameters like that. This is essentially used to generate those SPFs. So all of the SPFs, we look at similar, comparable roadway types, and that's based off of that segmentation approach. So if you want to do a network screening based off of segments, you can. We just break the roads again according to roadway attribute. Intersections, pretty self-explanatory. We break out the intersections and just look at the intersections themselves as standalone entities. The last network screening method is sliding window. That's where, rather than breaking the roadways up based off of roadway characteristics, actually break them up based off of length. So you can come in and tell us that you want to find your high crash half-mile windows, and we will find the highest crash count 1-mile windows or half-mile windows, or however big you tell us to look for. So, yeah, go for it, Brent.
I'll just jump in to say, kind of expand on the segment network screening method. Because that only segments the roadway where there's breaks in ADT, number of lanes, kind of major changes in the roadway, that when you do a screening using that method, that application, that sometimes, especially in rural areas, you can have long stretches of segments, so like 20 miles, or it can go across the whole county, where that methodology isn't as useful sometimes in those scenarios, and that's where sliding window, where you can control your window length, is more useful. So just saying, internally, we've kind of rarely used the segment application. It has its uses, but sliding window gives you that more control.
Yeah, no, thanks, Brenton. Thanks for hopping in with that. In fact, none of my examples today are even going to be using segment network screening. Again, the main reason for that segmentation is to allow the SPFs to be generated for that kind of predictive model. It can be used as a network screening method, but as Brenton said, there can be some challenges to it, and you can end up comparing a 20-mile stretch of road to like a 1/10 of a mile stretch of road, and that can be kind of problematic. So generally, as Brent said, Ohio uses sliding window. Frankly, a lot of the states we work with, again, will use sliding window for that same reason. So yeah, great clarification. Thanks, Brent. All right. Now it's time to hop into the applications themselves. So I've bored you enough with slides. Let's now hop in and take a look at network screening. So if you're following along, make sure that you log in to ohiodot.ashtoware safety, excuse me, the hiccups are back, .ashtowaresafety.com. And this is how you can access all of the sliding, or excuse me, all of the network screening applications. I'm going to switch my camera off here and we can focus on the applications. Okay. So high level, once you log in to ohiodot.ashtowaresafety.com, by default, it's going to take you into Crash Query. Now, we've done some trainings on Crash Query before. This is kind of the general data querying application. We are not going to be looking at this today. So let's actually go into our navigation bar up here at the top. If you click in the top left corner, you'll see here's network screening and predictive network screening. These are the two sections that we're going to be taking a look at today. Now, under network screening, again, you should not see these legacy ones. If you do, don't go into them. We're going to be removing those shortly. You should see intersections, segments, and sliding window there. And then under predictive, you'll see again intersections, segment, and sliding window. Mine might look just slightly different in this drop-down menu. Don't worry too much about that. As long as you're seeing these same tools, then you'll be fine. Let's get into our first example. So the first example that I want to run through, we're going to do a very simple network screening. In this example, we're going to be putting one together for the Wheeling MPO. Now, in this scenario, we want to look at a list of high crash locations. We want to identify our top 25 half-mile high crash locations and also our high severity locations. So again, we want to look at top 25, half-mile, high crash, and high severity. So let's get in and put that together. So I'm going to use sliding window. We're not going to be looking at intersections. I want to look at stretches of road. And again, I want half miles, so I want to go into sliding window so I can put that together myself. I do have to apologize when we round the corner on about 200 attendees and everyone's clicking on the button at the same time. It can lag just a second to open some of these applications. And sometimes I'll get that, which ruins my day. While we're waiting for this to load up, we did have a couple questions around how intersections are defined, how our segments are defined. We have dropped some help articles in the chat as well to help answer those questions. There we go. Hop in the chat, take a look at those help articles, and we'll make sure that, or those should answer some of the questions around how intersections are defined and some of the other functionality in there. So, all right, we're back. So again, I'm going to go under network screening, and I'm going to click on sliding window. Okay. Now, inside of the sliding window application, let me give you kind of a real high-level overview of the tool, and then we'll get in and start putting our wheeling MPO high crash location query together. Let's turn on the spotlight. There we go. Maybe, is that working? Hold on. There we go. Okay, so up across the top of the screen here, you will see our navigation bar. This is where you can navigate between applications, as we just saw. You can also access right here in this home icon, your library of saved screenings that you've put together. If you click on that home icon, you'll see it'll open up all of the saved screenings or screenings that have been shared with you. Next to that, you'll see the title of the screening that you're actually looking at. So this says here, new sliding window analysis. Over to the far right, you will see the default date range. You can customize this to whatever you'd like. So for this example here, let's say that we wanted to look at the last 5 years of crash data. So I want to look at the last full 5 years of crash data. So we're going to go back and look at 2020 through the end of 2024. So it's going to default to a rolling window of the last couple of years of crash data. To change that, just click on the dates. You'll see here it's looking at the most recent 3 years.
I'm sorry, Greg. May I cut in real quick? We have an influx of questions that just came in. And I think it's regarding kind of where you're at right now. So may I ask those real quick?
Absolutely.
Okay, good. So we have someone that says that they're seeing a message that says sliding window has not been fully configured.
Okay. Interesting.
We have quite a few people that saw that actually.
Okay. David, we might have a data set sharing problem. Can you take a look at that?
Yep, I'll look at that right now.
Okay, thanks, David.
I'm gonna go ahead and clear those real quick then.
Yeah.
Oh yeah, we had a bunch. Okay, hold on, sorry.
Is that what most of them were?
Yeah, yes. And then we had a question, is the network screening purely observed, and predictive network screening contains both predicted and expected?
Yes, yeah, that's correct. So network screening is purely just that observed, and then predicted contains both predicted, expected, and observed as well.
Awesome.
Yeah.
And also someone shared some feedback that they don't see the help articles.
Okay, so here I just put that response in at 8:31 that had the links to the help articles there. So
wonderful.
Should see those in the chat. If you don't, again, let us know.
Wonderful. And one last question, and then I will let you get back to it. Someone is asking, will there be a white paper or step-by-step instructions on how to identify the top high crash, high severity intersections after this webinar?
Yeah, we can absolutely put some documentation together. We actually are also going to have some saved screenings shared out with you that you will actually just open up that screening and you'll be looking at the results you need to. So yeah, we'll make that as easy as possible. And if we need to, we can put some additional support documentation together to run through that.
Wonderful. I will go ahead then. If once you get that put together, if you share it with me, I can go ahead and share it to all of our registered learners today, so they'll have that.
Perfect. Okay, thanks, Kara. And don't hesitate at all to hop in. Thanks for hopping in with those questions. I appreciate that.
Not a problem. Thank you.
Sliding window should be fixed as well.
Perfect. Okay, thanks everyone. So if you were seeing the sliding window error message before, you might need to just refresh your browser, and then it should be loading up for you now. So thanks for letting me know. Okay. All right. So let's start putting our screening together, and I'll kind of slow walk it a little bit so everyone can kind of catch up. Again, I want to start by adjusting our date range. By default, when you go into a sliding window network screening, it's going to be loading the most recent 3 years of crash data. You can control that. Just click on the dates up on the top. And I'm going to go into other right here. This is actually going to allow me to customize that date range. So I'll come in and I can define January 1st of 2020. And then in this example, I want to look at the last full 5 years of crash data. So I'm going to set this to run through the end of December of 2024. So now we're going to be looking at all of 2020, 21, 22, 23, and 24. Click apply, and then you'll note when I do this, it's going to refresh the map and it's going to refresh my table on the right here to reflect that updated crash data. Now, this is a really great example of one of the benefits of this historical network screening. Unless you need to use those performance measures or those more advanced features, this might be a great option for you, because you can really quickly hop in and change something like the underlying data. We essentially completely changed the data set we were looking at, and it re-rendered the entire state of Ohio pretty much instantly. Right, now for sliding window, there's one more kind of important option up here in this top navigation bar. All the way at the right, next to the save icon, you'll see that little settings cog. If you click on that, this will allow you to define the length of your windows. So again, this is how big of a stretch of road you want to look at. In our example, we wanted to look at a half-mile window length, so you can change it there. Now you can go down to 1/10 of a mile, or you can go all the way up to 10 miles. But we're going to keep this example at a half-mile. Now again, when I click apply, it's going to have to reload the network because again, we're redefining the entire screening here. So I'll click apply, and you'll see again, it's going to chew on it for just a second. And now we have our new results for the state. Okay, now high-level navigation for how to use the tool itself. Similar to our other tools, so if you've used Crash Query, it should be pretty familiar. We have our filter bar at the top of the screen. This allows you to control the locations as well as the crashes that are being utilized in your screening. So I can come in and apply a filter here and look at a specific type of crash or a specific type of road, and that will reflect in my screening. The right side of the screen here, this is your actual prioritized list. So you can see we're ranking here from 1 through 100. And right now you'll see this crashes column is highlighted. It's bolded and a little bit shaded in that column. This is saying that this is the current method we are ranking by. All of the other measures are going to be listed off to the side here. So we can see crashes, fatal crashes, crash rate, and EPDO. If I want to re-rank it by EPDO, for example, I click on that heading and it's going to resort and re-rank the whole network for us. So again, not going to take super long, but this is recalculating every half-mile stretch of, or actually every stretch of road in the entire state of Ohio, finding our top EPDO half-mile windows, and then working its way down across the state. So quite a bit of heavy lifting going on each time you click one of these headings. Now off on the left side of the screen, this is the actual map itself. Rather than showing crash locations, we're actually looking at the windows themselves. So if I click on a window in my table on the side, you'll see it's going to highlight it and zoom to that location on the map. So here's our stretch of road. Here's another one. You'll see it's just going to kind of bounce around on the map and show you those half-mile stretches of road. Okay. Let's put our screening together now. So right now we're looking at the entire state of Ohio. Again, going back to our example, we wanted to look at the Wheeling MPO. So let's put that filter in. We'll go up to the filter bar and I'm going to type in MPO with the geo parenthetical there at the end. So this is going to allow us to define any of the MPOs that we have a record for. And you'll see here's Wheeling down toward the bottom. So I'll click apply. It's going to apply that filter to the map. And now it's only going to show us our windows inside of Wheeling. And it's working perfectly well right now.
Greg,
yeah, go for it.
Kara again. It looks like we're getting some feedback from quite a few people that the map locations are incorrect. It's taken them to the wrong place when they're clicking into the areas on the map.
Interesting. Let's give me 1 second here. Okay, I am not sure what is going on here. Let me try another. Give me just a second and we'll see if we can troubleshoot what's going on here.
Wonderful. Everyone, stay tuned.
Thanks, everyone. Sorry, this is one of the downsides of doing a live presentation. All right. Well, I'm not entirely sure what is going on right now, but I can see. David, did we recently redo the LRS for Ohio?
No, I don't think so, but I can check with Clark real quick.
Yeah. This is not working correctly. All right, we might have to call a little bit of an audible here, and let's try to change this up and see if intersections is going to work for us. My apologies, everyone. We tested it earlier this week and it was working perfectly. And of course, now that I have 200 people staring at it, it's not going to work for me. So let's try this with intersections and see if that's going to work better. Okay, so let's pivot a little bit here. We can be adaptable. Let's change our scenario a little bit. It looks like there might be a problem going on with network screening sliding windows right now. I think it should be working in predictive. We'll take a look at that. Lauren, if you want to try just running that in that same search in predictive and let me know if that works. But let's shift a little bit and let's do an intersection network screening inside of Wheeling. So we'll do the exact same screening we were going to put together before, but instead of looking at half-mile windows, we're actually going to look at our high crash intersections and high severity intersections inside of Wheeling. So we'll just adjust the scenario a little bit here. Again, let's start by adjusting our date range here. And you'll see, again, this is actually great. If you know how to use any of our applications, you know how to use all of our applications. So you'll see the dates, the filters, the map, everything is exactly the same from sliding windows to intersections. Really, the only difference is what we're looking at. And here we're looking at intersections as opposed to those half-mile windows. So. All right. So we've got our date range adjusted. We are looking at the Wheeling MPO. Let's dig in and look a little bit deeper. Now, one of the things that can be really helpful as we put a network screening together as well is not just controlling the locations, but also controlling the crashes that are populating our screenings. It's really common to want to come in and remove certain types of crashes. So for example, if we wanted to remove any animal involved crashes or any other non-collision crashes, work zone crashes, we can easily apply those filters and remove those crashes from our screening. So to do that, I'm going to hop up in the filter bar and I'm going to put in the crash type description filter. Okay, so here we have our crash type description filter. And I'm going to exclude, so I want to change that operator to is not. And we are going to remove our animal involved crashes and our other non-collision crashes. So again, what this is doing now is kind of curating that crash data population to make sure that we're only looking at the relevant crashes, the crashes that we want for our screening. Again, if you want to remove those like work zone involved crashes, again, we can change this to I only want to look at my crashes that are not inside of a work zone. Now, we had a question in here around, let's see here. We had a question in here around urban and rural designations. If you wanted to kind of do a separate urban screening and a separate rural screening, and that's a real common request, especially from like MPOs we'll get a lot of times, right? Like if you have a major urban center and then you have some kind of rural areas in the outskirts, you might want to break those out and do two separate screenings. Maybe you do, maybe you don't. But if you wanted to, again, that's a great example of a filter. You can add your urban, suburban, rural intersections, and you can remove the either urban, suburban, or rural intersection. So if we just wanted to do like a rural intersection network screening here, I can just click rural, and you'll see that it's actually going to go in and remove all of the urban intersections here. So really easy to get a specific targeted screening. And again, all of what I'm doing in network screening intersections, you can do the exact same in network screening sliding window as well. I did want to plug one little thing really quick here. Unlike our other applications, we actually have two different kinds of filters that we can apply. You'll see here some filters say crashes, some filters say intersections. Now, they may also say segments or a sliding window as well. You're filtering two different things here. So let me kind of explain this really quick. Anytime you're applying a filter that says crashes, you're actually controlling the crash population. So you're going to be changing the available crashes that are going to feed into your ranking. So this is a perfect example. We're only looking at the crashes that are outside of a work zone. So that's going to remove a crash from this location. The next filter over, intersections, this actually isn't going to remove crashes. This is going to remove entire rows. So this is going to pull out entire intersections. So any urban area or suburban intersection, they've just been removed entirely from this screening. So it's kind of a nuanced difference, but it's a very important difference. One is actually changing the calculations, right? That's your crash filters. You're changing the underlying crash population. This intersection filter, you're actually just removing an intersection. You're removing an entire row of data. So it's not going to change any of these values in your crash counts. It's just not going to show that intersection in your screening. So hopefully that helps, but it was a great question around kind of the rural and urban divide. Another time that you might use this is if you're doing something like functional classification. So here with intersections, for example, if we wanted to look at major leg functional classification, we can remove any of like the larger functional classes. So maybe I only want to look at my locally owned, you know, and locally maintained. I can do the major leg of the intersection is local. Cool. This is now just going to show me my local intersections. So again, if you're looking for just, hey, what are the ones that I can control as a local? That's a great way to control that crash population. This can be helpful in segments and sliding windows as well. A lot of times you may want to remove interstates. You may want to remove larger functional class roads. That's a great way to get in and kind of customize your screening. Okay. Let's talk a little bit now about how we can rank our roads. So I've got my wheeling MPO intersections. We've removed animal crashes and other non-collision crashes, as well as any work zone crashes. So we're looking at the right data population. Now I just want to change how I'm ranking my roads. By default here, you'll see that this is ranking by crash rate. Now, crash rate takes the volume of the road into consideration and normalizes for volume. Crash rate is it's a performance measure that's listed in the Highway Safety Manual. You either love it or you hate it. There can be some biases and problems with crash rate. You know, for example, if you have an area that's got a very low volume but happens to have one crash on it, you'll have kind of an inflated crash rate. That's what it's ranking by default right now. Now, if I want to, I can just rank it by straight count of crashes. I'll click on this crashes column here, and it's going to re-rank my network for me and show me all of my high crash locations. And that was actually the first takeaway that we wanted, was we wanted our top 25 high crash intersections. So here we go, 1 through 20, looks like we got 2 tied for 24th. So 1 through 25, that's going to be our top 25. Now, if you want to investigate these areas closer, you can simply click on the location in the sidebar and it will zoom the map to the location. Now, this is, especially in intersections, this is really helpful because it's actually going to show you the geometry of the intersection itself. And defining intersections is a fun task. But Ohio actually has done a really good job of defining their intersections. So you should see some really clean, fairly straightforward intersection data here. You can see we've got a divided Highway 3 leg there. Yeah, Brent, go for it.
I'll jump in because I think this is, there's a question kind of similar to what you're talking about now, where somebody said they found an intersection can be duplicated. I'd be interested to know if it's a divided intersection. So unfortunately, the way intersections get defined, if it's divided, it's actually 2 points that has 2 intersection IDs. We try to clean those up by creating a complex intersection ID to combine the 2, but we don't have every single one because it's a lot of manual work. But if you do find duplicates, let me know. And if it's a divided, we can add it to our list of complex intersection IDs.
Thanks, Brent. And this is especially with intersections. Defining them is really tricky, really difficult. And frankly, until you look at the data, it's hard to really know what you're dealing with. There's a lot of intersections across the state. So if you do notice those anomalies, like Brent said, just reach out and we can kind of dig into them and investigate them a little bit further. But yeah, thanks, Brent. Let's see, so we did have a question, and Brent, I might need to tap you for this question as well. There was a question about, can we also filter by federal aid eligible? I'm not sure.
I don't think that's a filter in there currently,
okay.
no.
Yeah. Yeah, we can look into putting something like that together if that's something that would be helpful.
There might be an NHS if you search that, but I'm not sure about federal aid eligible.
We might need to decode that one. That's the only NHS one we've got. Okay. Yeah, we can look into that, but currently, yeah, that does not exist. So thank you. All right. Now Lauren's been working, Lauren and Dave have been working in the background here. It looks like there was a recent change to our LRS that we loaded in, and it did cause a little bit of a problem with a sliding window. It should be working now, so I'll hop over and we can take a look at that in a second. My apologies about that, but we'll kind of finish this example out with the intersections, and then we'll go over and take a look at sliding windows too. So, all right. Now, a lot of times we'll get questions as well. For example, here we're ranking right now by crashes. A lot of times we'll get questions around like, well, hey, I just want to look at my KAB crashes, or I just want to look at my injury crashes. We don't have a column for that necessarily, but again, by using your crash filter, you can come in and just put a severity is, and you can come in and choose whatever severities you'd like. So if we want to look at our injury crashes here, we can click apply, and then that is going to just show us, it's going to remove essentially our PDOs. So having that ability to filter out those crashes really can make this a pretty powerful and pretty custom ranking for crashes there. I'm going to save this out really quick, and we'll talk about saving and sharing these screenings, and then we'll start to look at some report output options as well. So anytime you put a screening like this together, make sure that you save that screening out. Do future you a favor. Chances are you're going to need to come back and look at it again at some point in the future. Go ahead and save it, and you can always come back and reference that again. So I'll click save in the top right, and it's going to open up a new saved screening window, and I can give it a title and give it a category. So I'm just going to call this wheeling intersections, and then I'll put it in the training category. And now when I open my library of saved screenings, I'll see there's my wheeling intersections, and it's going to open up all of my filters and my dates in my table exactly as I had it customized. Now, my top 25, there's a couple ways that I can output this, and I can kind of document this externally. On the top menu bar up here next to the date, you'll see this little download icon. This will prompt you with a couple different download options. The PDF report is a great way to kind of pull this out of the system and share it with people, include in reports, things like that. So I'm going to call this my wheeling top 25 intersections. And I said 25 and type 15 because I'm good at life. You can come in and tell us how many intersections you want to display, up to 50. I'm going to leave this as 25. Click generate report, and it's going to spit out this custom report for me here. Now this is going to show when it was created, who created it, what dates and filters they were looking at. It'll show the top 25 table, and here we can see it showing those first 3 performance measures. And then it's actually going to have a breakdown of the crashes at each of these intersections. And this is a really cool table. This is actually showing the legs of the intersection and the number of crashes and their severity. So if I want to kind of compare intersections to each other, I can easily do that and kind of have a record of these top 25 locations. Underneath the PDF report, you'll see the worksheet download. This is actually going to download a spreadsheet that will show all of the intersections that met our filter criteria. So let me pull this up here. Right, so if I go to the intersections tab, you'll see here that it's actually going to show 1,000 intersections. So even though my list in the app only showed 100, this is actually going to open that full list of 1,000 intersections here. So we've got our crashes, crash rate, and then even the severity breakdown for each of those intersection locations. So it's a really great export option as well. Now, if you're interested in pulling this into another GIS platform, we do have a geometry KMZ download right there that you can pull this data into another platform as well. So.
Hey, Greg, can you show a couple things real quick? I know we covered this in a previous training, but how to hide and show the columns, the button down there below the table, and then opening up an individual site location in Crash Query once it's on your list, so then you can see the crashes and everything.
Yeah, absolutely. Let's take a look at it. So by default, you're only going to be looking at a handful of columns right here. These are the performance measures, right? So any of these you can click and re-rank. You also have the ability to add additional data columns. So down here where it says hide show columns, I can come into this and I can actually add any additional column of data. So if, for example, I want to add, the route ID or the AADT, or if we have a traffic control or skew angle value, I can add any of those. And we'll see here that I'm not sure that's the right AADT. We'll remove that one. But here you can see we've got the traffic control and the skew angle that we're able to reference here as well. So any additional data point that you want, you can add that to your table, and that will also show up in your worksheet downloads. So that's a great way to kind of add additional data that you might want to do for any kind of external data processing or prioritizing inside of Excel. As Brenton mentioned as well, once you've found an intersection that you want to investigate, so let's say that we want to dig in here a little bit to this intersection at Main and Marion Street. If you click on it on either the map or in the sidebar here, it's going to open this little intersection preview. This will have a Google Street View of the actual location itself, so we can actually see what this intersection looks like. And this is really good for things like sight lines, skew angles, maybe there's some obstructions here. It's just a great way to kind of get eyes on the location without actually having to go out there. But this is really powerful because it will help you actually open this in our other applications as well. So I can click open in and go straight into Crash Query from here. And this will actually open this location up in Crash Query, which is going to allow us to investigate these 29 crashes a little bit better. So here you'll see it's pulling over our intersection ID, and here's the crash population that we're looking at. And now I can dig in and see the types of crashes that occurred, when they occurred, and all of my kind of Crash Query level data analysis. So that's a really great workflow and a great way to investigate these areas further. Because again, just because it ranks high, let's actually look at the crashes. Let's see if there's a fixable problem here. And you can do this with any of these intersections. You'll see that open in Crash Query option available. Right. Now, one more thing I wanted to talk about here, once you've saved and customized your screening, over to the left a little bit here, you'll see this share icon. This is going to allow you to share this screening out with other users as well. So let's say that Brenton and I are working together on this analysis, and I want him to take a look at my screening to make sure that I've got it correct. So I can click Add User, and then I just type Brenton's name out, and we'll see there's Brenton Bogard. I'll give him, click on his name, it'll automatically pull his email over, and then I can either give him edit or view access. If I only want him to like reference it and look at it, we can give him view access, but I actually want to work with Brenton on this one. I want him to be able to add columns and to customize filters. So I'm going to give him edit access. And now next time Brenton goes into network screening intersections in his library here, that will show up, the wheeling intersections will show up for him. Now, if you want, you can go under your shared with me and that will screen out just the ones that have been shared with you. Yeah, there we go. Now, I want to hop over and take a look at some other network screenings as well really quick. I want to also put a pin in here. I have shared, we've put together and shared a couple intersection screenings with everyone. I'll circle back and talk about these at the end, but everyone should see this roundabout and always stop control candidates screening in there. So those have been generated and shared out with everyone. But we'll come back and take a look at those a little bit later with one of our examples. So
I'll answer one question while you're switching up about the ADT from Matt. I don't think in network screening, it doesn't look like ADT is visible as a field in the table, but if in predictive network screening, you can unhide columns of all the different years of ADTs for the locations you're looking for. So if it's not a network screening, and maybe I'll add that to my list to look into if it's something that needs to be added there, but either in Crash Query or predictive network screening, you should be able to add columns that show you what the ADTs are.
Yeah, a great call. And I think you're thinking there, Brent, of like, hey, if it's not in the historical observed network screening, try it in predictive. That's a really good approach. Predictive is always going to be more robust and always going to have more options and more flexibility. So if your first attempt in the historical or observed screenings doesn't give you what you want, my first action would be exactly that, open predictive, and it will likely have more data that you're looking at. Again, that's because in order to keep the historical or observed screenings quick and rapid, the data that is available is a little bit more constrained. But here you can see in predictive intersections, we've got all the historical AEDTs showing up as available to add as columns too. So yeah, great call out, Brent. Okay, so just to circle back on this example, because I know it wasn't working earlier and we had some questions about really weird geometry showing up. That has been fixed. Huge thanks to Clark on our data side who was able to hop in and fix that for us really quickly. Just to save what little face I can, let's hop in and throw this wheeling filter in now and we'll show it actually functioning. So there we go. Better late than never. So here we can put together that exact same screening that we were looking at before. So we'll do wheeling, change it to 5 to half-mile windows. I'm going to actually have this built out already. So we'll open that saved screening up and take a look at those results. So this is, again, the same screening we were putting together before. You'll see here I removed principal arterial and interstate routes, but I also removed our animal and work zone involved crashes. And we're looking at our high crash and high severity locations for the wheeling MPO. So apologies about that little hiccup, but it should all be working and functioning now. So, okay. All right, now one of the limitations that we've talked about, and we've talked about a couple of them now, one of the limitations of just a standard network screening, not a predictive network screening, is the performance measures that are available. We can only look at crashes, EPDO, crash rate when we're doing that historical analysis. We also are limited to the number of results that we can see. So I can only see 100 windows right now, and I could only see 100 intersections. We talked about some of the data columns that are restricted as well. In fact, within sliding window, I don't have the ability to add any data columns for reference when I'm doing a historical. So let's take a look at this same network screening, but built out in predictive network screening. So We're going to put the same screening together. We're going to do the same wheeling, remove these crashes, remove those functional classifications, change it to half mile, and we'll kind of just do an A/B comparison, and we'll take a look at predictive compared to a historical network screening. So I went to predictive network screening and then just clicked the sliding window option. Now, by default, you'll notice right here that we are removing our work zone, animal, and other non-collision crashes by default in our predictive network screening. The reason is these crashes are removed when we do the SPF calculations. So our SPF crash population does not contain these crashes at all. So we're removing them by default when you open any predictive network screening. So that's actually great because that's one less step I have to do. So now I can hop in and apply my same MPO filter, and you'll notice that it's going to work exactly the same. So we'll throw that in, and we'll see now one standout that you've probably noticed already is we're seeing a lot more than 100 results. In fact, we are looking at 1,000 results that are being visualized here on this screen. So one of the big advantages of predictive network screening is not just the ability to do the more complex calculations and rankings, but also a larger data set. So even if you're going to still use those historical screening methods, it might be valuable to do it in predictive network screening. In fact, I like to think of predictive network screening as more of an advanced network screening. So don't let the word predictive scare you off. Even if you're doing just a historical analysis, it might be best to use predictive network screening just to show the data that you want. Another difference here within predictive network screening is you'll see we have a lot more columns of data. By default, we're going to show you the street name, the route, the beginning and ending mile point. There's our crashes, crash rate, and EPDO. You'll see now we also have predicted crashes, expected crashes, potential for safety improvement, and M-loss. So those additional performance measures available. So if I want to rank by PSI, which is the difference between what the SPF predicted and what we actually saw at that location, I can click on PSI and you'll see we have a completely new map that we're looking at. We did have a question, do the windows overlap each other? They do not. Once crashes are claimed by a window, that crash cannot be double counted by another window. So the windows can butt up against each other, but they cannot and won't overlap to double count those crashes. One other note as well, the sliding windows will count intersection crashes by default. So if we look at any of these locations that have any intersections in them, so here, for example, we've got an intersection, a couple intersections, a couple ramps here as well. It's going to grab all the crashes through those intersections. So be aware of that. Okay. While we're looking at predictive network screening, you'll see the same filters that we were looking at before. A lot of filters will have this little lightning bolt next to them. That means that you can apply that filter without having to do any calculations, without having to save and reprocess your screening. These are the screenings that are going to remove rows of data, right? So if I want to remove like functional classification of road, I can easily do that. So we can, remove here our freeway and interstate, click apply, and it doesn't need to recalculate anything for me. When it will need to recalculate is if I'm changing my crash population. So if we wanted to, for example, do a pedestrian screening, you'll notice that that's not going to show up as a filter option. If I want to show all of my filters, including the ones that will require me to regenerate my screening, I actually have to click this little button down at the bottom and then it will open up all of my columns that I can filter by. So here, pedestrian involved crashes. Let's change that to yes. And it's actually going to prompt me with this little dialog box and say, hey, the screening you want to run doesn't exist. It's going to take a little, and I'll give you a quick heads up. Those times are not completely accurate. They're generally significantly quicker than it says here, but it is going to take a little bit of time. So this is telling me, hey, in order to put this pedestrian screening together, we actually have to go through and recalculate all of the data for the entire state. So it's going to take us about a day to do that. Finish applying your filters, get your screening dialed in the way you want, and then click this save and run, and it will actually, let me show you here. Click save and run, and then it's going to run in the background here. Now, a really nice feature is you can check this box and it will actually send you an email when the analysis is done, and it will say, hey, your screening's done. You can come in and access it now. You don't need to stay on this window at all. You can hop away. You'll see that it's going to show up here as processing. So yeah, again, not a huge deal. It'll generally take a couple hours. Sliding windows as a rule is going to take the longest because there's the most recalculating that needs to take place. If you're doing an intersection screening, that should go significantly quicker to save and process those. Let's talk really quickly about a couple other screenings that we have put together and kind of shared with everyone. I'm going to stay here in predictive sliding window. And if you're following along, go over to the shared with me. Now, under shared with me, you will likely not see all the ones that I have here. Instead, you will probably only see a handful. One of those is going to be right here, this curve analysis that I put together. So I haven't shared it with you yet. I will right now. Now I'm going to share this with you just so you can kind of look at it and use it as a template to kind of like, see how a screening can kind of come together. But this is a really good screening that we put together doing a curve analysis. So this is a great example of how you can put together some real custom values, including crash filters and sliding window filters to really target a specific kind of location. So let's read through what we have in this screening really quick. Again, we've removed our work zone, animal, and other crashes. I'm looking at Columbiana County right here, but you can easily remove that and change it to whatever you want. But these two filters right here are really interesting. The first one is road contour. So here we're only looking at crashes that are flagged as having occurred on a curve, either at grade or a grade curve or a level curve. So we're only theoretically looking at locations that have a curve. This next one is I'm only looking at locations where the crashes are greater than or equal to 2. So I want locations that have at least 2 crashes. Now I could change that to fatal crashes, I could change that to severe crashes, whatever you want. But in this example, I'm just looking at a location that has more than 2 crashes. So this is essentially a curve report that we're looking at. Right now I'm ranked by crashes, but again, I can come in and rank that by EPDO, or I can rank it by any of my other predicted or expected performance measures here. So here, if we look at our highest severity, so again, we're ranking by the weight of the severity crashes that have occurred here. This is in Columbiana County, the highest severity curve that we have in this area. And again, if I want to dig into that a little bit more, I can go into crash query and you'll see it's going to pull this location up for me. Now, I really like this example in Open and Crash Query because it's not going to pull over all my filters. It's just going to pull the location over. And I can see here the crashes that are occurring around this curved area of road. So this is a really helpful screening. And again, I like this kind of analysis for curves because you can target a specific type of crash. You can target a specific type of location. So I've shared this out with all of you. If you want to use this screening, you should all have just view access to it. So if you open this screening up, just click the create a copy. There you go. You should see a little create copy button in there that will allow you to duplicate this screening, or you can come in here. Well, it looks like we don't have that in there. Well, shortly you should see a create copy button that we're going to add in that'll allow you to kind of duplicate this within network screening to use as like a template. So you can drop the county geo filter and it won't need to re-render the screening at all. So drop your county geo filter, you're looking at the whole state, and then you can drill down to whatever specific location you'd like. So that's a really cool screening we put together for you. We've also thrown a couple different screenings together too. So if you look in network screening intersections, either predictive or historical, you'll see a couple other ones that we put together too. So go to the library of saved screenings, and here you should see an urban intersections, all-way stop control candidates, and roundabout screenings as well. These are, again, templates that you can kind of open up, put whatever additional filters you want in there. And this is kind of a pre-populated screening that you won't need to generate. It's not gonna, you won't have to wait a day to process it. Just come put your city, district, county, MPO filter in. You can even draw a polygon on the map, and it will show you all of the urban intersections that meet the filters identified in here. So again, we're looking at urban, non-work zone, non-animal, non-other collision intersections from 2020 to 2024. These next two, the all-way stop control and the roundabout screenings, these are really cool. Brenton and his team put these together. I came in and saved some copies of them out and updated one of the filters. And this is showing you all of the candidate locations where, in this example, the major leg AADT is below about 7,500. And then here you can see the actual type of roads that we're evaluating. So this should be really targeting just the kinds of intersections and the volume of intersections that are good candidates for an all-way stop control. So again, throw your county filter in, throw your city, your MPO filter in, and you can have a really good all-way stop control candidate location. These ones also have some really cool ranking criteria in there. So here we're looking at fatal and all injury SPFs, and you can actually see the SPF listed out right there. So these are looking at essentially all but your EPDO crashes. So you can come in and rank by those different performance measures, or you can again just rank by the count of crashes. So really cool way to do a very targeted network screening of potential areas that could benefit from all-way stop control. Similarly, this predictive screening for roundabouts has been put together that essentially does the same thing, except instead of targeting all-way stop control candidates, this time it's targeting areas that are candidates for roundabouts. So I love these examples because not only are they just great to have in your back pocket, you don't need to go through and reinvent the wheel, but also it really shows the potential of putting together targeted screenings. So if you have specific criteria, right? Like I want to look at this kind of intersection because I've got a countermeasure in mind, build that screening out. And then this will actually just make your life a lot easier. You can do kind of network screening, diagnosis, and countermeasure selection all as kind of one unified step. So screen for your countermeasures, and then you'll see that you've got those priority locations identified for you. Again, all of these have the same download options: the report, the worksheet, and the geometry download as well. All these screenings, the roundabout screenings, the always stop control screenings, they're also in the historical network screening as well. So here you can see the roundabout and always stop control candidates as well. So you don't have to do them in predictive, you can do them in either one. But those are kind of shared out for you there and are available for you to kind of use as some starting points, some templates to get into. I did want to mention, I'm sorry I didn't mention it when I was in there. Let me actually take a look. We do show the SPF that is actually being used in some of these screenings. So if we go to this always stop control candidate, you'll see here the actual SPF being used. If you download this as a worksheet, I'm not going to do it because it'll download the whole state. But if you download it as a worksheet there, you can see the entire SPF that's actually being used. So again, transparency, these are all based off of Ohio crashes, Ohio roads. And we want you to be able to see how these values are being derived. So transparency on that. Ooh, really good question. Brent, I might need to tap you on this one too. Is there a filter to only look at local or ODOT maintained roads?
Yeah, there's some maintenance filters. If you type, I thought there was.
Sorry, I'm just looking at an abbreviated list. There we go.
Yeah, I think that's probably the best one, other than maybe functional class, obviously. But I think that between those maintenance filters, there's an ODOT maintained one and a local.
Yeah.
So play around with it. If you search the MAINT, you should find all the different maintenance filters. Hopefully that helps.
Yeah, that's a great help. Thanks, Brent. So yeah, through some combination of these, you should be able to find that maintaining authority to help you kind of pull out either targeting the locals or pulling out the locals as well. Ooh, another good question here. Ramps. Do we have so we do have a ramp ID. I'm not sure, Brent, the reliability of that.
Yeah, we're working with David and Clark to create a separate ramp application. So the goal is to pull out ramps from intersection analysis, from segment analysis. They'd be their own thing because they kind of are their own thing. But right now they're mixed in with everything else. So unfortunately, you'd have to play around with some filters to try to get them out of there, or just ignore them if they're showing up in your analyses.
Yeah. Okay. Thanks, Brent. Awesome. Well, those are all the examples that I had that I wanted to kind of run through with you all today. I know it seemed like we spent a lot more time on that first example, but again, that was kind of teaching the mechanics of how the application works. Once you understand how the applications work, then again, it's pretty straightforward to come in and just define your specific screening area. We've got another minute or two to answer any questions that might be coming in. But Brent, is there anything that you wanted me to cover that we did not mention yet before we hop into the Q&A?
No, I don't think so. It seems like a lot at first. The more you play with it, the more comfortable you get. But I think you did a good job. And yeah, I'll jump to one question that seemed to have come up quite a few times about adding data like volumes. The volume data that is being ingested into this application is coming from ODOT Technical Services. It should be what's in what shows up in TIMS or MS2 through the years. So if there's issues with that data, I mean, you can send it my way. Ultimately, it's would be forwarded on to tech services that hopefully they can then update. But no, you don't have control to change the volume. What else? Control of correcting inaccurate data. So you can't move, maybe if it crashes in a wrong location, you can't physically control that or move that, but you can message us and we will get it moved to the right location. And I think we have a link. I'll try to put it in the chat real quick of that process that helps us do it quickly. So yeah, just answering a couple of those questions.
Perfect.
All right, and I just have a couple of last minute questions that we had come in quick, and then we will be able to wrap it up so that everyone can get on with their day. Benjamin Turin asked, I'm not sure if exactly what he means by this, but he's asking, did you cover PSI?
Ooh, so we talked very, very briefly about it, but I can do a really quick explanation about what PSI is. So PSI is actually the difference between the predicted crashes, so what the SPF model thinks this roadway should be performing, and what the actual empirical bay's expected value was. So it's kind of the difference between how other roads perform and how this road performs. So in this example, we had a predicted crashes of 0.09, but we actually saw our empirical bay's actual performance was 0.6. So this actually has, there's a delta of 0.52. So again, the difference between those two, this is actually 0.52 higher than the predicted model was projecting. So in a real high level, very quick overview, that's essentially what PSI is. How much does it deviate from comparable roadways, if that makes sense?
Wonderful, thank you.
Yeah.
And let's see here. Kessa asked, she's wondering about if this handles the extra data needed for full ECAT analysis, like driveways, schools, etc. No, she said, never mind HSM analysis, or if it's only handling road configurations.
I can kind of answer that. It's right now it does not. As far as I know, I mean, I'm sit on a committee with other states that are kind of helping to develop or add different features into what AASHTOWare Safety calls alternative design. So that is something we are looking into to try to replace ECAT to see if it's feasible and what features can be added to make it a little more streamlined as far as data entry.
Great, thank you, Brent. Okay, let's see here. Someone is asking if you can elaborate on, I'm going to mess this up, I know it, MLOS or MLOSS term?
Yeah, so MLOS is actually very closely related to PSI. What it's essentially saying is how much higher above the prediction is that PSI. So MLOS is broken into 4 categories: MLOS 1, 2, 3, and 4. MLOS 4 is the highest deviation above the prediction. So if it is 1.5 standard deviations above the SPF, then it's going to have an MLOS of 4. If it's between the SPF and 1.5 standard deviations, it's going to have an MLOS of 3. Anything that has an MLOS of 2 or 1 is performing better than the SPF predicted. So there's kind of some complexity to it, but essentially 1 through 4. 4 means that it is performing significantly worse than the SPF predicted. 3 means it's performing worse than the SPF predicted. 2 and 1 means it's performing better than the SPF predicted. So that's kind of drawing it out really fast in crayons. That's kind of what loss means.
Wonderful. All right. And last question, everyone. It says you had sliding window values at as one of the filters. Can you share how we can use the different options and values?
I'm sorry, can you repeat that one more time?
Absolutely. It says you had sliding window values as one of the filters.
Mm-hmm.
Can you share how we can use the different options and values?
Yeah, so let's go back here to my sliding window example. Let me find a good one. Okay. So again, going back to the different types of filters that we have, you can filter out in sliding windows, you can filter out crashes, which is going to change the crashes you're actually looking at for your calculations. Or if you see any filters that have this little sliding window parenthetical after it, those are actually just going to remove the roads themselves. So a good example is if I filter out pedestrian crashes, then all of these crash counts are going to change. But if I just remove interstates, then only the interstate rows are going to be removed. None of the values will change, right? This road still has 400 crashes on it. This road still has 391. I'm just removing my interstate sites themselves. So those sliding window or intersection or segment filters, those are essentially just removing an entire site from the analysis, not necessarily adjusting the crash population. So again, if you just put a parenthetical and type out sliding window, it'll show you all of those different filters that you have available. So really pay attention to that little parenthetical at the end. That's telling you the type of filter that can be applied. Great question.
All right. Well, thank you so much, Greg, for that insightful information and presentation. As I mentioned earlier, the recording of this webinar will be shared with all registered attendees. Before you leave, we'd really appreciate your feedback. A very short 4-question survey will automatically launch in your browser once the webinar ends. It only takes a minute, and your input helps us improve future sessions. So, in saying that, thank you all for attending. We hope you found this webinar very informative and engaging, and have a wonderful rest of your day.
Awesome. Thanks, everyone.
Thanks, everybody.